live in the habitat.
Okay. Hi everyone, I have a laser pointer. So if you're not quiet, I will point the laser at you. Good. Okay, I'm Adam Greig, or Random SKK. I'm from Cambridge University Spaceflight.
I'm Daniel. I'm still in the last year of secondary school, so yeah.
We've been working on habitat, basically, and that's pretty much what this talk is about.
So we thought we'd sort of start with reintroducing you to the tracking system as you know it, because you might not know what goes on behind the scenes after you just put a sentence into DLF or Digi and it appears on the map. So we'll also sort of explain why we're doing this, and then sort of the whole habitat as it is.
Cool. And we'll be running through kind of how you use it, depending on what you're using it for. So there's a bit of a, I don't know, guide in the talk, as well as some technical details. Okay, so the old system, which we all know and love, and worked brilliantly for very many years, and you know, it wasn't bad, given especially how quick it was put together, consisted basically of a lot of listeners in DLFL Digi, which we've all used, which uploads their telemetry to the listener script, which was on one server. That listener then kind of passed the script using a single massive PHP file.
Sorry about that.
It's a great detail. The best part about the PHP file is that every time someone needed something changed, it just got added onto this file more and more and more and more. And I'd also used this XML-based system for working out how to pass different payloads to telemetry. And that data was then uploaded to a separate server, spaced near us, which was the tracker and has a pretty map and draws the payload on the map, shows all the flight stats. There's a kind of very linear flow diagram at the bottom, which is roughly how it works.
So yeah, as Adam said, the listen script got quite large with tons of different modifications to accommodate what everyone was doing and so on. In addition to spacing out code, although that was split across several files, there was sort of modifying the 2500th line that made it display someone's pressure instead of the temperature or something like that, just like rather than having some sort of configuration. Didn't say quite bad things, and you couldn't get if you wanted to do people started using our CouchDB habitat display our own page if they just want. Also, separate server. So like you had people posting data on the server, it was parsed, packaged in a different format, saved in a database on that server, posted to another, saved in a database on that server, repackaged and then given to your web browser, so it's a bit confusing.
So also it's like if you're in a race car and what you really want to do is see where and maybe even work out where it's going to go. If you don't have internet access, it's difficult. So a lot of people had to make all their own programs for it, and sometimes you got kind of patchy internet access, and it would just start loading near us, and it would drop out for uploaded, and then eventually just phone some internet access and ask them where it's going to land. And you're like, yeah, but I can't use Google Maps either. Where's it? I'm in a field.
And where are you? Yes.
So that was a thing which would have been quite hard to kind of patch the old system into doing. So, what we wanted to do was basically these bullet points, modernise and unify all the tools into one project, which was kind of well designed from the ground up to be able to be extensible and support all the things we wanted, and that anyone could contribute to. That was kind of, here's the code, and also it's running on this server. Not here's the server, this is also the source of the code. If you want to work out what it's doing, log in and open up the PHP. But please, and it be really easy to extend and add interfaces. So you're doing your own little thing, you're using, I don't know, some specific mapping software which has great maps for your local area, you want to get at the data. There was kind of a way you could do it before, but it basically involved repassing all the data yourself, whereas we wanted it to be a really easy, clean interface. Here's your data, it's already passed, you can just grab it, you can have it offline, whatever. And those were really our design goals.
So we're using CouchDB, and we thought we'd have a quick introduction to what it is, and I'm going to sort of give you a tutorial and using it because it, we needed to introduce it because it's so different to SQL. And I imagine there's quite a few people who are familiar with SQL but won't be with CouchDB. So it's DB for database, but it certainly doesn't have tables or queries. At its heart, it's just a store of documents. You can think of it as files, but that'll do. And it's all in JSON. So, and it's just basically, it's a disk with a load of JSON documents on it and a web server. And then they do some clever things to make it actually useful. Unlike MySQL, typically when you use CouchDB, you have everyone be able to access it. So we're not using, well, we will eventually be using it in this way. But if you wanted to write a web application with CouchDB, you would have JavaScript talk directly to the database, and you wouldn't have any PHP or Python in the middle. Instead of queries, you can't do queries because it would take too long. It's not written in C, it's in Erlang, and it uses JavaScript to do the query code, so it would take way too long to query the entire database. Instead, we have the concept of views, which is you define a rule, you give it a rule on how you want it to sort your data, and whenever you save some data, it will sort it and prepare it. So when you say what is the latest payload with this call sign, it'll say I worked that out ages ago. It's this.
So it maintains the views in effect, as you said,
That's
the data
right.
it maintains the views rather than actually query the data.
Yeah, so it trades off disk space, which we have in abundance, for CPU time and memory at runtime. If anyone's familiar with MapReduce as a kind of way of processing data, this is basically what it does. A view contains a map and a function and a reduce function, so it can calculate the map and reduce every time data comes in, and then you can get out back already calculated data really quickly, which is nice.
And one of the other advantages of it basically being a web server glued onto a database of files is that it's really easy. It's got a really easy API to use. So for example, it's ridiculously easy to ask it to tell you when something changes in the database, and all you need is just some JavaScript, Ajax, or whatever your favourite web client is, and it will just tell you.
Okay. So this is a kind of very high-level overview of the new system we've built up. Essentially, CouchDB is right in the middle, everything talks through it, nothing really has to talk to it, anything else besides the Couch database. So DLFL Digi, right now it doesn't, but the latest version, which will be rolling out shortly, will talk directly to CouchDB, and we'll cover how it works at the moment in a second. The parser is a totally separate bit of software that just watches the database for a change, and then when someone's uploaded some new raw telemetry to the database, the parser grabs that, works out what the data from it was, and puts it back into the database. In the meantime, anyone else can still be writing to the database or reading off from it. It kind of takes an eventual consistency approach to a CAP problem if anyone's keen on databases. Finally, the web interface to come is just going to be HTML and JavaScript. It can talk directly to the database again. So nothing has to communicate except through the database, which is where we can maintain all our persistency. All the data is there, it's all archived. If anyone wants to kind of look at flight records from, I don't know, flights ages ago, you can just go on the database and say, hey, remember this flight, and there it is. So we kind of move away from massive text files full of raw telemetry, which eventually get copied into an old data folder and renamed, which is nice. It maintains its kind of accessibility over time.
I think originally when we started out doing Habitat, there's a sort of slide on the history, but when we started out we said, okay, we'll have something, post something to the parser, and then the parser can save it into the database. We changed to this module, this sort of way of doing it, because it was just a whole lot easier to have one central database, and it means that the parser is nothing special in the terms of uploading data. So something else, when we could add a daemon that, for example, fixes errors in telemetry, and that could talk the same way that the parser does. So we don't need to extend the parser; we can just add something new.
The other thing that's really nice about Couch, and especially by having Couch in the middle like this, is that it's very, very easy to replicate. Because anyone can access the database directly, as opposed to going, you can do effectively master-master replication. Every copy of the database is as good as any other. And anyone can do this anytime they want from the main database. So if someone goes, oh, I want to actually get a copy of all the data, because I don't trust these HapHub guys, they might go down in a second, they can replicate from the database.
It went down twice.
In fact, we can now run multiple servers and have the database replicated across them, so it makes it much easier for us to maintain uptime and reliability. because it's so easy to do. You literally just have two instances of couch running. They can cross-replicate, and then they're both the same. If you can run a parser on one or the other, it handles merge conflicts really nicely. So it doesn't matter if you upload to one or the other or both, or one of them parses or the other one. It basically all sorts of stuff.
On the laptop, would you look to have couch basically running with a copy of the data on it, and in effect that be your master copy when you're running around?
So yeah, this is kind of one of the ways in which it becomes very easy to support offline chase cars, which we'll get to fairly quickly here in fact.
So in addition to sort of renovating the old tracker, we're adding some new stuff just because our design on how we're redoing the tracker makes it easy to add these things. So we're thinking, as Andrew just said, you put CouchDB on a laptop, you put some HTML and JavaScript on your local web server, and you've got HubHub, and that's it. And then you tell it to sync with the main server, and suddenly you've got everyone else's telemetry on your laptop and your telemetry on everyone else's computers. And the best bit is the CouchDB doesn't mind if your 3G drops out, if you sort of go through a tunnel. It just doesn't care. When the internet comes back up, it will synchronize. So we're going to sort of kill the whole thing where you have to ask someone to upload your flight. Instead, you can manage it yourself. We'll give you sort of an interface where you can say, I mean, you started using something Adam made already. I'm so sorry.
Not that you drag and drop around it.
I was playing too many choose your own adventure games, and that was basically a product of it.
But basically, we'll be able to modify that so that at the bottom, instead of saying paste in this and tell someone, it just says load, and then your flight's on the tracker. Oh yeah, easy access. I can't remember exactly who was using it. I think it might have been the Apex guys who were using this a few days ago. But yes, I don't know. It's in our logs. Basically, someone comes onto IRC and says, "How can I tell where my payload is now?" So use this URL, and you just get some JSON, and it tells you exactly where your payload is. Extensible. So I mean, obviously we've created it, and it parses telemetry in the UKHAS format, but there's nothing special about the UKHAS format in terms of Habitat. It's just another module. So you could plug in an SSDV thing, or if you wanted to make a binary protocol, that would be fine. You could just plug it in, and as long as it takes some data and produces some latitude and longitude, then it'll work.
Or not even latitude and longitude, yeah, just really anything. Okay, so kind of getting on to how you actually use the system as a user. For trackers, so people who are kind of listening to payloads but are otherwise sitting at home and really, I don't know, being really helpful people in this whole network, you can continue to use DLF or Digi as you always used to. It's basically the same as before. There's a new version coming out soon with a really nice new interface made by Daniel, which has kind of, instead of one massive drop down of all the payloads, you can start doing things like search. You can see testing documents versus actual flights. If a flight has multiple payloads or multiple projects on the same balloon, for instance, you can select between them. It lets you do lots of kind of neat things like that. But also, because the protocol is now kind of documented and open, easy to add things to, you could write your own radio decoding software and not use DLF or Digi. So if you had some specialist requirement, or you had a different RTT-WISE modulator, or anything like that, you could very, very easily, it's like a single HTTP request, post your data. Someone else in the future might make some other software. I don't know, maybe some integrates with Flunkey dongle or whatever, which would work, might be for now.
So if you're a ballooner, as I said, you now manage your own flight document. I think it'll certainly be easier for us. I think it'll be easier for you guys as well. It's got all the information that the old documents had, but a little bit more. Sort of, I think that the way of using the old XML files was that you would file for your call sign and then update it if you change your telemetry, and that would just stay on the server, and that would be it. We're sort of changing it slightly so that a flight document describes one flight, or you sitting in your garage and testing the payload. It doesn't describe it's only got how your telemetry looks inside it, but you'd need to make a new one for each flight. That's not going to be too difficult. You just say copy the one I used before. But this means that because you turn all of your data into flights, testing, flight, it means that we'll add really easily. We said, oh, October, with that. And of course, as always, we help with the changeover, and we're doing as much as we can to make sure that the changeover from the old system, at the moment we're sort of in a state that's halfway in between. You might have noticed a few things breaking. That's probably because we were trying to glue Habitat into the middle of Space Near Us and the listen script. But we're always happy to help fix problems, like I see in email.
Okay. So as a brief interlude, we've talked a lot of nice things about how anyone can just access your database and how you can add your own flight documents and all this kind of thing, which is fantastic. But this is the internet, where there are lots of big bad guys kind of out there. And what you don't want is someone, I don't know, spamming your database, someone drawing out an advert on the map or whatever. That would be bad. Someone just an answer.
Dark side.
You know, there's a lot of scope for people to play silly pranks or malicious pranks, even delete the whole database. That would be really tragic. So we've got a lot of stuff in place to kind of prevent that. One of the things in particular is that for flight documents, the idea is put in a testing flight document and you update it. When it's in that database, it will use up a little disk. Not really too concerned at the moment. But on DLF or Digi, this then shows up under the testing section, so it doesn't spam everyone else using DLF or Digi. What you then do is, when you actually have a flight, you can put in your flight details when launching and all that, and a couple of people, the same people who now upload XML files, can just go, this looks fine, click, and it's approved, and that flight then shows up on everyone's DLF or Digi list. And when you go on the tracker page, you have a list of current flights, and those will be approved flights. So it stops people easily spamming the thing. In the same way, test flights, if you look at the map, don't show up unless you actually go to look at them. So when you're testing your payload, it's really easy to do. You just go, yeah, test flight's mine. But if you're just there to look at an actual flight in progress, you only see ones that someone said, this is a real flight. So it kind of helps keep things under control there. And there's, yeah, the final point here, flight docs are safe, the archive's protected, everything's backed up, but also B, there are kind of things in place so people can't just overwrite all the old telemetry or delete it or anything like that. We'll come to that more in a second.
You can't put any dodgy stuff in a flight doc that will crash the server or get you shell access or anything like that.
It's escape to
Yeah, it does a lot of kind of clever things, like some of which we'll come to later, but code signing and other nice things.
So, if you're chasing a balloon, then it's suddenly got a lot easier to you. We were thinking of, we were sort of saying earlier about how we could run CouchDB on your laptop. So we're sort of thinking of sort of giving you a disk image, which you run in your favourite virtualization software. If you haven't used it, it's really easy. You'd sort of like download a few hundred megabytes, and then it would work. It would just be the difference of browsing to a different URL in your browser. It would work exactly the same. You'd tell DLF or Digi to send it here rather than to HabHub, and everything would be fine. We can also we could bundle the predictor in that. We can put everything in there. I mean, everyone certainly has laptops. I think some people have done sort of custom things in their cars where they'll have I don't know exactly, but it's sort of, this will be a lot easier than hacking something together and trying to put in mapping software and tracking software and a predictor into the car. It'll just sort of like drop in disk image and it'll work. Yeah, and then it'll work. It'll synchronize.
Okay, so people who are just kind of watching flights, now you just go to one page and it's all one really nice web app, so you can get at the predictor, you can get at all the archives of flights, you can get at the current flights. That's still really easy, you just go on the page and there's the current flights. The idea is to make it all kind of nice and modern and pretty. I think you've probably all seen the new Space Near Us format, which looks really nice. So probably a bit like that, but with a few more options hidden away to do stuff like predictions and the rest of it. And also, again, because it's open source and on GitHub and all that, anyone can go, oh, actually we need to do this and we can do that. It makes it fairly easy for us to add new bits and pieces to it. So hopefully people who are watching flights get a better experience and kind of more fun.
So some extra stuff to look forward to. We mentioned an archive of flights. We're just not going to delete anything from the database. So you've made a flight so that it'll play, and then as soon as the day's over, it just goes into the archive. It doesn't need to move around. It's just sort of on the web interface to say, oh, that flight was yesterday. This is an archive flight. Someone can look at it. So you can load up the web page, and instead of saying I want to track a flight, I want to have a look at yesterday's flight, or 2.5 years ago. I think Rob has actually got quite a lot of data from the old system.
The last 4 years worth.
He's got 4 years of data which we plan to import, so that as soon as we switch over to the new system, there'll be, I mean, if you find browsing through old flights interesting, then you can do that.
Pretty much all the flights that have ever been uploaded to the old system are available. So we should have almost every single flight that used the old system in the archive once it goes live.
And we can do fun things like have achievements. We can have automatic. We could also, for example, it's so extensible that we could automatically work out how far you are from the payload if you upload where you are in DLF or Digi, and then maintain a sort of high score table. And it's all kinds of fun stuff that's on the bottom of the to-do list after we've done all the features.
It's like achievement unlocked, heard something over 100 miles away, you know. Achievement unlocked, launched a flight, this kind of thing. First person to receive, I don't know, last string before it hit the ground, all of this kind of thing. It could be really easily done, and it doesn't even need to be part of the main system, you know, it could run wherever because the data is easily available. So there's a lot of scope for kind of, I don't know, adding on fun bits and pieces. So for admins, this isn't many of you, but the people who used to upload XML files and hack around on PHP scripts and the rest, we've now got this hotfixes system, so you can write a tiny piece of really nice Python, and it just runs, and it runs against that one payload's incoming telemetry, not everyone's. So if someone's like forgotten a plus sign on their coordinate system, or like the minus sign breaks, or that integers overflow or go unsigned or something silly, you can just write a small piece of code to fix that, and it even has utilities to like then update the checksum for you because the checksum's changed because you changed it. So it's really easy to add little fixes to payloads, and also people make, because like it's easy to add common changes if people keep making the same mistake. We don't have the XML system anymore. We're going to have the really exciting web interface, so you just say, here's my payload, here's what the sentence looks like, click go, that's it, no one has to copy XML files around. And yeah, flight titles, it now does all that automatically, so basically if you're an admin, which is like, I don't know, 3 or maybe 5 of us, life's a bit easier, a lot easier. So that's nice.
You need an admin to apply the hotfixer, am I right in thinking that?
Sorry?
You need an admin to apply the hotfixer.
Yeah, so the hotfixes are actually a small piece of Python code, but because you could do a lot of damage with that, they're code signed using certificates, and we've got a CA for Habitat, and then all the people who are going to be writing them can get their certificates on the system, and there's a really neat script to just sign your code and it will run. If it's just a really common thing, like someone's put semicolons in instead of commas, which some people do because that's what it used to be, and you can now just change that to commas without needing to be an admin because it's just a defined action. So it works both ways.
So if you're a developer and you fancy using the data in, well, this down here is a picture of HadHound, which some Phil's been working on. If you fancy using it in your own website, your own application, as I said, you can get it all via HTTP. It's surprisingly easy to use in whatever language. If you're fancy using a scripting language, then it's ridiculously easy because there will almost certainly be a CouchDB library, and you can just say, I'd like to use this database, and I want this document. Yes, there it is. It's an object. If you're writing in C, it's still surprisingly easy to do. All is a web server and a JSON parser. It works fine. If you're a developer and you want to help out with Habitat, that'd be great. Just sort of hop over to GitHub and you could fork the repo, and then you can change it, you can send a pull request, that kind of stuff. Besides that, I'd say come on to IRC. We sort of have a channel where we keep all our spam relating to Habitat away rather than the main channel, #HapHub. But essentially, yeah, talk to us on IRC if you want to do that. And yeah, I didn't mention on HapHound, this is actually using OpenStreetMap's local data rather than the Google Maps, so you don't need to download all the mapping. So I presume that will work really well on Chase Cup.
Tell me more, you don't land next to your laptop.
That's right.
Except there are gaps in the street map.
That's fine, you can update your street map and find gaps. It's like, oh, actually there's a road here.
I'd rather find my payload than find the gaps though.
Anyway, so slightly more technical details on how it works. We've got this couch database right in the middle, which is really important. Everything talks to it. It's the API, so you want to access data, you access Couch. You want to upload data, you upload it to Couch. You want to get some calculations on the data, it does the map produce for you, all of that. It's how the different services communicate. So DLF or Digi doesn't talk to a parser, it just puts data into Couch, and then the parser reads Couch and passes it, writes it back. It's where we persist all the data, so stuff doesn't end up stored all over the place, it's all in Couch. These blocks are kind of more into how Couch actually knows what to do. each part, like the parser for instance, has what's called a design document which holds all of its views, which are like queries. They contain MapReduce things. Filters, which say, like if you're watching for changes, the parser has a filter which says give me all the new unparsed telemetry, and that's all it gets, which is what it wants. And also validations, which is really important things that say, no, you can't overwrite this telemetry, no, you can't delete this thing, no, you can't upload this random piece of junk. Basically, all data in it is web accessible. As we've also said a few times, the service can replicate so much database space. It's no biggie. We want more computational power, it's no biggie. The address of ours, and it downloads all the data. So it does lots of kind of nice things for you.
A question: does it prevent the bad data getting into the system as well? Does it actually analyse the data? So you just jumped halfway across the world. That can't be right. Data. Does that allow you hoping to check some?
I think bad
so
data
it depends on what you mean.
Bad data is in sort of malicious.
No, bad, not bad as in malicious, bad as in erroneous data.
So the malicious data can still be uploaded, but the parser's been responsible for saying actually this isn't useful and not passing it, and then the database center is uploaded because there's no point junking it forever. It's like a single string, but it either won't get passed, or if it does get passed, it doesn't then show up on the map. So we filter it to the parsing stage.
So so the cache DB reviews are great, but they can't do things like parse telemetry. It wouldn't work. We need to have a view can only run on one document, and we have several involved in parsing telemetry because there's the configuration document and there's the document that contains the string you just uploaded, and if it's something like SSDV, there'll be all of the other documents containing previous data that's been uploaded. So instead we have a Python program that runs all the time, watches for changes as we said, and then parses it as soon as it's uploaded. I mean, you'd think that there might be a slight delay, but it's barely noticeable. It's very, very quick because the CouchDB, although they don't have to be on the same server, in our case the CouchDB server and the parser are running on the same machine. But the daemon, it's an idea that isn't specific to the parser. So as I said, we might add an achievements daemon or something that calculates statistics for a flight and saves it back into the database so people can have a look at it. And you can run that on any server because the parser uses the same interface to talk to the database as everyone else in their web browser, everyone at DLR for Digi does. The parser is slightly special in that it'll have a login that lets it modify telemetry, which everyone else won't be allowed to do, or they fill it with garbage. But besides that, you could run one of these on any server at all.
So the parser itself is kind of the really important bit of the system. It turns the incoming strings into actually useful data. It's configured by the flight documents you mentioned before, which you can just write and test by yourself, and there's a handy web tool to generate. The web tool that actually works in more than just Chrome if you're lucky later. So it looks at the flight document, that describes what your telemetry is. It's basically like the data VX, and it can use that to work out how to pass the data, but it's a bit more extensible because you have filters if there's some mistakes in incoming telemetry, and also a bit more extensible input senses. You can use it for, say, SSDV if you're sending pictures, or if you want to do some kind of exciting new format, it supports all of that in the same kind of config interface. So the parser modules are things that handle natural protocol. The flight document tells it what module to use. So UKHAS protocol, which is what basically everyone uses, but if you're using something else, that would be fine. SSDV is the thing that I think has been kind of worked on. So it can parse that as well and do a nice job of it, store the pictures in the database. Yeah, it kind of does clever stuff to work out what module to use, but it basically works.
So while we're sort of changing it over, at the moment, the parser and the sort of basic database design are almost finished. So we thought we'd sort of start using it for flights, and for quite a while now it's been used to parse data from flights. So what we've done is we've replaced the listen script with something that just forwards data to us, and then that's uploaded to Couch, and then it's dealt with in the Habitat way. And then we've replaced the script on the else DLF or DigiWhat the page flights there are with something that asks Couch what the flights are, and it converts them to this sort of disgusting XML document. And then finally, there's another program running that connects to Couch and says instead of watching a filter for new telemetry, it watches a filter for past telemetry. So whenever the parser successfully parsed something, it gets uploaded to the tracker.
Okay, and then the web interface is the bit that's kind of we're mainly working on now, because Space Mouse is lovely, but it's still Space Mouse thing, so we're kind of working on the Habitat version, as it were. It's just going to be JavaScript, so there's no PHP, there's no MySQL database, it's just JavaScript and some HTML and CSS. So it can sit on a laptop, it can sit on our server, runs wherever, and then it talks directly to the Couch database, which is great. It does all off different payloads. You could look at the archive of flights and all the rest of it. I'm writing predictions to go through it as well. So the predictor can be another daemon that kind of just sits on the server, and then when you file a prediction request, that goes onto a database. It means we can then have all the predictions in the database, which is kind of neat. It makes it easier to put it in chase cars, but it also means you could do things like stats on predictions. You could say, oh, here was the last prediction before we launched. How far away were we? And then in like a year's time, you can go, oh, we've had 100 flights, and on average the predictor was, I don't know, 12 miles accurate or something. Probably not, but so that'd be neat. And equally, you can write your own web apps, because as we have kind of repeated a lot, the data's all web accessible, which is a really big thing.
Can I put one plea in as well, and that's when you do that tracker, the hub version, can you make sure you get that bit where it centres on it when you're driving around? Because one of the worst things about driving around in the old system before we got that sort of keep it centred, that was...
Yeah, sure.
I almost crashed the car 3 or 4 times. Drag it back onto the back.
Probably a good time to mention, but this is also where it's really easy to make a mobile version of it. So you go to it on your mobile phone, and then it uses the nice mobile Google Maps thing and has a nice mobile interface, and then you can actually use it on a phone as opposed to the current one, which you really can't use on a phone because it would make you sad. Okay, so to kind of wrap up.
Yeah, we just give a quick overview. It started quite a while ago, and we made some progress. We discussed a lot of ideas that really didn't go anywhere, but it sort of really kicked off this year. We tore out quite a lot of the stuff that turned out to be a bad idea and wrote the parser and some basics structural stuff, and I think that's pretty much where we are now.
What we're going towards is the new web interface, which is going to be really exciting. The offline chase cars, which we want to make really easy, like you just click this button, it goes on your laptop, you're done. The predictor integration would be nice, and also especially if the predictor ends up in Python instead of C, that would be cool. Achievement system, I think, would be a lot of fun. Any clever ideas that anyone has, really, we can just shop them in, pretty much. Yeah, cool. Questions?
I'd like to integrate a different predictor. We've got an algorithm that uses the send data, predict the bandage lock. Can we do that somehow?
Yeah, really easily. So because we've got on the server, it's already got all the telemetry that's come in so far on the flight. So you can just look through it, get all the send data, and then output a new prediction.
Is that under interest, or do you think it's might be better?
We'll find out. We'll find out, but I mean, it's not bad. I mean, my Zaben payload already includes it and it transmits the position.
Well, because that's what we used to do.
Yeah.
But I thought, I was never convinced.
He was never convinced.
But it's
Well, it'll be interesting to see.
Yeah, I mean, that flight I did to Belgium, 6k out.
Okay.
I'll
show you a
like,
data point.
300 kilometres flight.
I'll show you a data point later.
You know, isn't the normal predictor using the same concept, though, isn't it? It's still a balloon.
But ours old data, isn't
Yeah.
it?
It's using data from places that were near to where the balloon is to calculate, and 6 hours old data to calculate.
We can run them both.
Yeah. Absolutely. Yeah, the competition. Achievement section.
To be honest, the real key to it is the descent speed, and
Yeah, it has to.
and everybody has to guess what that's going to be unless you run the flight before.
Something I've noticed is there's step changes in the prediction. So if you get the NOAA data or something, there'll be a step change in the prediction once they move to the latest forecast for their weather model.
On the 6-hour shift point.
Yeah, so it's not like it'll be an interpolation of what they think is going to happen.
No.
There'll suddenly be a big shift in what their wind prediction is. So if you're towards the end of, I've forgotten what the time period is, a 6-hour window or something, if you're an hour before the end of that 6-hour window, say, your weather prediction could have got quite inaccurate, and then suddenly it'll shift to a new prediction. In an hour's time, it might actually be quite accurate at that point.
We used it quite intensively for the stuff I'm talking about this afternoon, and I'll show you a data point from that, but it can work really good.
Oh, luckily, occasionally.
I mean, the thing about it is also is that it doesn't, well, only a few of us talking in this conversation, is that, yes, it's 6 hours out, but the predictors also use a lot for planning your flights, and so we've all seen it the way that actually it's narrowing it in and better. So actually, even though the 6 hours is not that far out, in comparison to when you started doing it 3 days before. Yeah. So you don't get the large shifts in data because the accuracy improves, if that makes sense, the modelling itself is
modelling
better.
is better.
Yeah. So, but you're right, if you've got real-time data, then in theory, you'd think...
Well, that's right, I think in theory...
But is it that this makes it accessible?
Yes,
so
that's
you
right.
not be accessible in some ways. Not real-time.
Yeah, I just would just like to be able to have a little switch that says, use this version of prediction, use that version of prediction for landing spot.
It sounds easy.
Can I just say, guys, you've done a really good job on
Yeah.
this stuff. I mean, I've had some crappy code IO kicking around for a while, and James has done some wonderful stuff with FL Digi.
Daniel's rewritten the whole.
But to be fair, you guys have done. I mean, we were just amateurs basically playing playing a game, and you guys have done a superb job. It's just stunningly better than it was.
Okay, any more questions on
Just see if there's any questions from IRC.
Oh, someone asked about the support IE6. Okay.
Couch supports it, you can look at the raw data on your screen if you want.
Punishing them out.
There's a lot of kind of fun stuff. We're thinking of having a text message thing where you text in, like, I don't know, to a shortcode and it texts back to the latest position of your payload or like predicted landing spot or something. It sounds like you can do that really easily, like, I don't know, 20 quid a year or something on the service. You can just text it and text back to the landing spot.
Yeah, SMS to email is a free service for that.
Although, because the reason I like SMS is that often when we're chasing and we're in the arse end of nowhere and there's only about half a bar of signal and you can just about get a text through, but Google Maps has got no chance. And it'd be useful to get the latest prediction once you're on top of it.
And also battery life on your phone. Yeah. That's what kills you, is you're like trying to use 3G at the edge and your phone just goes, yeah, dies.
But to be fair, that's been a thing of the past, isn't it? We're talking about having mapping software on there that doesn't need to be connected. You're getting the data that's coming straight through live.
The only difference, I guess, is if you aren't listening to it or you're relying on other people who have heard it on their radios, then you can, and you don't have internet, you can send a text message.
You must be really lazy if you can't be asked to listen to your own payload while you're But that, yeah.
Isn't that why we built the system?
Well, I could go to the phone.
You could go to the pub and everyone else is tracking for you. I'd like to see this system used in other applications. I guess it could really be, you know, while it's focused at balloon stuff, you know, there are probably other areas. And in the opposite way, the APRS was set up in a sort of a generalized system, and now you can use the balloons. You could easily expand this to track anything, really.
Shitting.
It doesn't even have to be moving, it's sort of like a system where some data gets passed into some other data, so it doesn't necessarily have to be a position.
So you're getting back to the fundamentals of the couch, aren't you, at the end of the day? So we'll basically just store it for you. Thanks.
Great.
Thank you. Say clap on IRC. I don't know how you clap on IRC, but just put clap. Thank you.
Well done.